Good evening guys, my name is Musa Chulungumana and welcome to this video tutorial on assignment 8, which is dealing with terrain analysis. Just to give you a brief theoretical background into the assignment, as you know, the Earth's surface is not flat, and basically it has different areas of different elevation levels across the surface of the Earth. Therefore, this has an impact in terms of urban planning activities in regards to infrastructure planning, identifying areas suitable for human settlement planning, areas that are susceptible to flood risks, as well as other applications in regards to the engineering field. Basically, this assignment is just basically show you how GIS can be used as a tool to identify areas that are suitable for human settlement development, particularly on flat terrain, areas for infrastructure planning and development, such as your water and your sewage and your underground infrastructure, as well as identify areas that are prone to flood risk and therefore installing the necessary mitigation measures to prevent floods in terms of flood lines and so on. So the first part of this assignment is just to give you a brief theoretical introduction into it, and just to give a brief introduction into our digital elevation model. So just getting started into the assignment, you basically have three layers. You have your Johannesburg shapefile, you have a Gauteng shapefile, and you have your South Africa digital elevation raster model. So you have two vector data and you have one raster data set. So our raster data set, which is our South Africa DEM, is at 90 meter resolution, and basically this is showing the different areas of elevation across South Africa. So just to give a better application of it, as you can see, it's in 3D. I'll switch my raster dataset to a color that's more applicable. So I'll change my symbology, and I'll change that to a more convenient color that can be best illustrated. Into that, and I'll click OK. Then, as you can see, it's actually showing the different areas of height. So if I come to my actual layer, so elevation, basically your sea level is basically here. As you can see, this is around your Pietermaritzburg, your Durban area. As you know, sea level is at 0 meters. And then, as you know, with South Africa, as you go further north, the elevation rises. So as you can see, this particular white area here, which is actually the highest point of the valley, around 3,400 meters elevation. This is actually around your Drakensberg area, particularly around your Lesotho, around your Pietermaritzburg. Then as you get to Gauteng, you get to almost your Highveld area. So as you can see how the digital elevation model basically shows different areas of height. The other thing also to take to be cognizant is actually the digital elevation model and how it differs from your vector data set. So the digital elevation model is actually a cell by cell actual structure. Basically, it's actually divided into small square cells. So let me actually change. I don't know if you can actually see it here. So you actually can see the actual cell of each particular digital elevation model, and then each cell actually contains a value in terms of height. So if I click on my identifier tool and I click on this particular cell, it would actually show me the height of this particular cell, which is at 1,514 meters above sea level. So in terms of theoretically speaking, let me just zoom out. Let me just right click and then zoom to layer. So basically, this whole data set is actually divided into cells, and each miniature cell contains a value in terms of their elevation. So if you want, you can add a base map and just basically see the actual different areas of height in terms of the actual terrain. So I think this concludes the first part of the assignment, just to give you a basic introduction into our digital elevation model and raster data sets. So in terms of the next the next part of the assignment, we're actually going to focus on actually creating contours and slopes, so carrying out a spatial analysis, surface spatial